Hi, in this video, I'm going to talk about the characteristics of IP. Okay, so IP, both Internet Protocol version 4 and Internet Protocol version 6, there's three characteristics we're going to talk about. It's connectionless, which means no connection is established before sending data packets. I'll talk a little bit about that in just a moment. Best effort delivery. No additional overhead. There's nothing part of the IP header that guarantees packet delivery. And we'll see that we're going to see that there's another protocol that takes care of both of these that we call TCP that is actually in the upper layer, the transport layer. And the third thing we'll take a look at is that IP is media dependent. Meaning it doesn't matter what kind of link it goes over. It's just the packet. Think of it like a package. Okay, it's just a packet. It's the package that goes back that can go in the back of the truck, the back of the bicycle, the back of the boat, back of the plane, wherever. It's just the payload. Doesn't matter how it's actually delivered. At least it doesn't matter to IP. All right, let's take a look at some of these in a little bit more detail, at least introduce these somewhat here. Okay, so IP is both connectionless and best effort. Okay, so connectionless. What connectionless means is that when the host is going to send a packet, let's say we have the client here sending to a server. Connectionless means as far as IP, and we're just speaking about IP here, as far as IP's role, its job, there's nothing within IP that says, hey, it's not my job to tell for the client to tell the server that a packet is coming. My only job is to get the packet from the original source, the client, to the final destination. There's also nothing within IP that says I have to do any kind of guarantee that it gets there. I'm best effort. If somewhere along the way the packet gets dropped, it's not IP's concern. It's not its job to let the destination or the original source know that the packet's been dropped. So if IP is both connectionless and best effort, what if we need that information? We need the data delivery of the data to be guaranteed. Well, we will see in later videos, that's actually the job of TCP at both ends, both from the client, the source of the data, and the destination, in this case, the server. Think of it as a connection, first of all, the connection part of TCP, and we'll take a look at this in later videos. But it's kind of like if you were going to be sending a package to somebody, okay? You might call them up first and say, hi, this is Rick. I'm going to be sending you a package. Is that okay? And they say, yes, that's fine. I confirm, I acknowledge that you're going to be sending me a package, and I tell them back, you know what, I acknowledge that it is okay with you, so I'm going to be sending you a package. That's kind of the connection part. So before any data is actually sent, both ends, the client and the server, make sure that it's okay that this data is going to be sent. And we'll take a look at the details of this later. So this has to do with TCP. TCP also guarantees delivery. Well, again, we'll take a look at this later, but we're just kind of getting a little example here. What TCP does is when the information is sent, it's going to guarantee delivery. It's going to make sure that it gets there in order. It's going to, if there's any information that it doesn't arrive, the receiver will let the sender know that it didn't get all the packets. Again, we'll see how this works later, but it's kind of like that phone call I made to tell somebody I was going to send them a package. After a couple of days, 3-4 days, they might call me and say, Rick, I haven't received that package. And then I'll have to go, you know what? I need to resend that to you. All right, so we'll take a look at that in more detail in later videos. Okay, but again, as far as IP is concerned, it's not its role to form a connection or to guarantee any kind of delivery. One thing about IP is that it is media independent. What we mean by that is the IP packet, which includes all the upper layer protocols, can be delivered over almost over any kind of physical medium, data link and physical medium. The IP doesn't care. So if we have an IP packet here, it doesn't really care what the data link header and trailer is going to be. That's data link there. Doesn't matter if it's going over copper Ethernet or copper serial or optical fiber or, again, copper Ethernet or even a wireless network. The encapsulation of the data link header and the data link trailer, that's only for, again, NIC card to NIC card communications on the same network. Think of it, could be, I've used this analogy before, but it's like taking the package, right? We have a package, and whether that package goes in the back of a truck or a bike or a boat, doesn't matter to the package itself. Doesn't matter to IP how it physically gets delivered from NIC card to NIC card on the same network. That's the job of the data link protocol. Okay, that's the role of the data link protocol, to deliver the contents, the data of the data link frame, the data, which is IP in this case, from one data link NIC card to the next data link NIC card on the same network. So I hope that helps give you a little understanding about IP's role, or some of the things it doesn't do, but it's best effort. There's no guarantee. It's connectionless, so the sender doesn't inform the receiver ahead of time that the packet is coming. And both of those things are the job of, in this case, the upper layer protocol, TCP, that we'll talk about later. And it's media independent. As far as IP is concerned, we sometimes say IP over anything. IP doesn't care how you get it from NIC card on the same network. That's the job of the data link protocol.